probability and is specifically number of outcomes. So this question is a kind of a typical scenario when it comes to doing different calculation for number of outcomes. A 7-letter code is made using the letters A, B, C, D, E, F, and G. Now, very often in your question, it could be letters, it could be word, it could be numbers as well, but the idea will be the same. Each letter is used exactly once in the code. Okay, so therefore, the first part, again typical, how many such codes are there? So I can create a 7, 1, 2, 3, 4, 5, 6, 7 letter code. So the idea we are using here that when I'm looking for the number of outcomes, we are multiplying number of options available by number of options, by number of options, by and so on, by number of options. So if I'm looking at the first space, the first place available number of options are all the letters, and there is 7 of them, therefore I have 7 options. Now, since I used one of the letters on the second place, now my number of options is limited to 6. Then again, if I go to the third place, now I use 2 letters out of 7, so I am left with 5. And you are right, then there is 3 and 2 and 1. And all of those multiply. We multiply number of options in order to get the number of outcomes. And we put that in the calculator, press equal, and we have our answer. Now, there is a shortcut in writing for that. We can write 7 factorial. So an exclamation mark means basically that from 7, I'm multiplying down all the way to 1 numbers by each other. Okay, what about part 2? How many of these codes are the 2 vowels A and E together? So here this situation is slightly different. So I have this vowel together and then the rest of the code. So again, when I'm looking at that, I'm looking at number of options. So here, if those 2 are together, so that's my 1 option here. And then, so if out of 7 letters I remove 2, I am left with what? 5 letters. So that means for the second place, I have 5 options, isn't it? And then the rest is the same, 3, 2, and 1. However, now the difference here that we have to consider is that AE can be here and can be here and can be here and can be here and can be here. So altogether it has 6 spaces. So the next line, let's say if I have that line, the next line will be that first I choose one of the 5, then I put my AE, then I have the 4, the 3, the 2, and 1. And just like that, I can move that AE from the first place all the way to the last. So therefore, there will be 6 of those options for where that AE can stand together. Now, additional to that AE actually has 2 options in itself because I can have AE or I can have EA. So that means 2 options for that. So here, first, if we look at it, first I am considering number of options for that code of 6 spaces. Then I am saying, okay, that in itself can move, and so can every other letter move. And then at last, I'm saying, well, that can as well have 2 options. So that's the reason why there is so many numbers multiplied by each other. And again, when we put that in the calculator, we get 1,440.